where I believe there was some confusion, and which is kind of natural if you are trying to okay, so the homework was the division part, and then there was this divide 7 by 4 or 3 by 4. Now for the division part, all of you have done it correctly, but you needed to do the writing simultaneously. That you haven't done, but I'm guessing that you got the idea. Okay. Now, when we are, getting into 7 by 4 or 3 by 4, if we try to follow the array strictly, then we are going to run into a bit of a trouble, which here Sri Bhavani has run into. See, she has nicely divided 4 of the ones, and then there are 3 remainder ones, which again she has subdivided into 0.1s, and then divided 0.8, divided 28 of them, and there are 2 remaining. Okay, so this part is perfectly correct, but it's not complete yet. There is one more step to go. Now, if we go along one more step, then what happens is, if we want to continue in this way, then these things, these will have to be divided further into very, very thin strips like this. Okay. So these will, each one of these will be 0.01. Okay. And then if we kind of, then, so if we split them, then there will be 20 of them and 5 of them will come here, right? Okay, and that will add to another 0.05 here, and so the total will become, the quotient will become 1.75. Okay, so this is going to become 1.75. Right. So that part is fine. The only thing is, when you split this, these are pretty thin rectangles, these 0.1s. When you split them into, into 10 thinner rectangles, those rectangles become too thin, and you can imagine them, but physically having them is, very, very difficult. Okay. So that's why the array doesn't work perfectly okay. But if you go with the array, then this is how it kind of looks. Okay. If you were to try this on a dot sheet, not dot sheet, sorry, centimeter graph paper, then I would recommend use these things. So for one, you use 10 semi by 10 semi square. For 0.1, you use 10 semi by 1 semi rectangle, and for 0.01, you will use 10 semi times 1 millimeter, very, very thin rectangle. Okay. So that will complete the visual that you have put here. Okay. But as I said that, if you are doing with manipulatives, it's a bit difficult to imagine and deal with. So there is an alternative, which again, one of you have used. So let me show that to you. Okay. Now this is a much better representation. Okay. So what is happening here is that, you are basically going by the idea of Flatslongs's unit. So this big one, these orange ones and this one, these are ones. Okay. Okay. Let us, yeah. I don't think, yeah. So this is a 3/4, not a 7/4, but the basic idea is pretty clear. So since 3 cannot be divided into 4, so the 3 has been split into 30 0.1s. Okay, so that's what has happened. These blue ones, these are 0.1s and there are 30 of them. So if we want to write simultaneously, so this is what happens. Okay. So you are trying to divide 3/4. So you are not able to divide at the first round. Okay. So that's what happens. Okay. Now you put a decimal point and put a 0. Okay. And see, this 30 you have here is nothing but that 30 0.1s that you have. And you have distributed 28 of them. Each of them account for 0.7. So there are 7 of them amounting to 0.7. So that's what you put here. Okay. And then you have 2 of them left. And that's what you have split into smaller squares, which are 0.01 each, right? So, so when you make this 2 into 20, these 20 are basically 20 0.01s, which you again distribute equally, and you distribute them in, and you get 5 each. So that's 0.05, which you can just, you can just put a 5 here. That's equivalent. Again, if you want to imagine this with arrow cards, then you get that, it works just perfectly. And so that's how we kind of, complete the step. Okay. So whatever these so actual value, including the decimal that is getting that is being taken care of here and here, the numbers, when you go from 3 to 30, it indicates number of pieces you have. When you are going from again 2 to 20, it indicates the number of pieces you have, and you know the rate of exchange, right? So every time you basically split it into 10 equal parts. So if you have 3 here, and each of these 3 is split into 10 parts, you total end up getting 30 smaller pieces, right? So whenever we add a 0 at the end, it is like 10 times more, and this is what is happening. Okay. So this is the basic idea when it comes to division with decimals. Okay. So let me stop here and ask, is this clear? Is this making sense, or do you have any question?
No, Swati, it's clear.
Yeah. Especially whoever raised this last time, if you can unmute and say, that will be good. Okay. So the key thing to bring to notice is like what is happening when we are going from, we put a decimal here and then we keep adding these zeros. How to make sense of that? What is happening? So this is how you make sense of it. Key Every time we further subdivide it into 10 equal parts, so we get 10 times more pieces, and that's why, it's becoming a number 10 times bigger. That's basically the rationale. Okay. But usually we don't explain these to children, and it becomes like, you just add a zero at the back and it, mysteriously works out. But this is basically what is happening. Okay. Okay. Now that was part one. What was the other thing that you wanted to discuss? Please remind me. I mean, somehow I vaguely remember something to do with negative times negative or something like that.
I remember that she asked last time how to explain 21 divided by 2 in long division algorithm.
21 divided by 2. That we had talked last time, right? So 21 divided by is very similar to this. Okay. So you divide, 10 each. I mean, it's difficult to put both the 10 and 0.1 in the same picture. It will kind of look something like this. Okay, so you will have to draw a line like this. Okay, if we go with the quotient, etc., then here are the ones. You're dividing by 2, so these are the ones. Now, because you have 21, so here comes the 2 tens. Okay, and then the quotient will also be a 10. So far what has happened is, so you are doing okay, so you have distributed 20. I insist that you write the whole 20 and not just the 2 below the 20, the 2 of 21. And this is, you have distributed 10. Okay, now you have got 1. Now notice you cannot distribute 1. So, that's why you can actually do this if you want. Okay, and so you have got, now you comes the decimal, and you split the 1 into 10 0.1s, and then you distribute them. So they will look like, now this is, it's possible to draw it, but it will be difficult to do with material. I mean, having both 10 and 0.1, it is a bit difficult. Okay. So you have distributed them. There is 0.5 in each. So this can, the same thing can be drawn here too. That's 0.5. Okay. So that's what comes here. 0.5. So, okay. And yeah, so all 10 has been distributed and we are done. Okay. Another way you can think of it is, okay, so you are dividing 2 by 21 by 2. So at the first round, you are distributing 2 tens. So you do need to write a 20 here. Now, if you want, you can just put a 1. Now, this one above these two means it's a 10, right? And then you got this one. And now now you cannot divide by 2, so you are distributing 0 units right now. Okay, so you take that into account, and now you can put the 0. Then comes decimal. Okay, so now you have got 0.01s. Okay, and you are distributing 5 of them to each, and that takes care of the total 10. And yeah, we are done. Okay, the beauty is that there are 5 of them, and where you are writing the 5, that basically boils down to adding a 0.5. This is the beauty of place value or any base system, that they kind of take care of these things themselves. Okay, so this is where the digit by digit long division works so perfectly. You can think of it both as you are adding 0.5 and as you are adding 5 pieces. Both ways it kind of makes sense. So does this take care of 21 by 2?
Yes, Swati.
Okay, I mean, I would recommend do some things where you can play with the manipulatives and exchange and divide, those kind of things. So maybe more stuff like, and you need to divide by 2 or 4, because beyond that it will be difficult. So make sure you don't go, the quotient is not more than 2 decimal places. Okay, and once children get a little bit hang of that, then you can bring in something like 21 divided by 2 or 4 or something like those. Okay, so yeah. Okay, so this part we are done. Division with decimals. What next?
I have one confusion on introducing the square roots to the children.
Okay, okay, we'll do that.
Especially when it is like a not perfect square number.
Right. Okay. So if it is not a perfect square, then you have to do the division method, right? There is no other alternative. Okay. So okay. Starting point. Okay, have I ever discussed this square root with you? Ever? Anybody remembers anything?
No, no Swati.
Okay, so but you know the division algorithm of square root, right?
No, Swati.
Okay. The funny thing is, okay, the theory that you need to deal with the division algorithm of a square root, okay, is there in all middle school textbook, okay, usually around class 7 or 8, okay, and the division algorithm of square root is also there around this time. Unfortunately, these two are never connected up. Okay, I will share an article with you which deals with it in great details, but here is the rough idea. I'm going to draw a picture, and you will have to tell me which identity it represents. So the ones that look like square are squares, and the ones which look like rectangles are rectangles. All sides which should be equal are equal. So there are basically two lengths, two different lengths, as you can see, a bigger length and a smaller length. Now, which identity is represented by this picture?
A plus B
Plus B was
square.
Exactly. And that's the theory behind our algorithm. Okay. So it's very clear that the longer length is A and the shorter one is B. Right? So that's basically the assumption with which we are going. So now give me a number, let's say a 3-digit number. Yeah, let's start with a 3-digit number maybe. It doesn't need to be a whole square. And let's try. I mean, needs to be a perfect square. So give any 3-digit number.
678.
678.
78.
Okay. So now the whole notion is kind of like this. So you have this square and its area is 678. And what you want to find is you want to find this length, okay, this side, and that is square root of 678. This is the basic idea. Okay, so connecting the square that children learn in geometry with the square root and square of number in number or algebra. Okay, so this is the basic idea. So how can we find that? Now here we do a kind of approximation, and what you need to do is you need to observe that for single digit numbers, for numbers 1 to 9, you get it's a 2-digit, the squares are 2-digit numbers. If you go from 10 to 99, you realize these are 3-digit numbers. Okay, 3 to 4-digit numbers. Okay, and if you keep going like this, for 3-digit numbers, you realize those are 5 to 6-digit. I mean, the squares are 5 to 6-digit numbers. Okay, so you clearly get a pattern like this, and some of this is pretty obvious because you know that 10 to the, I mean, if you have, let's say, and this is, let's say, okay. So if you have 10 hat n and you are squaring that, okay, so this is a, then you will get 10 hat 2n, right? So this kind of holds for no matter what the what n is, and basically this thing is n plus 1-digit number, and this is 2n plus 1 digit number. Right? So, in this case, so this part, you need to arrive at, you can do tables and various other kind of thing, but you need to arrive at this one. So now, if we have a 3-digit number, then you know that the square root has to be a 2-digit number. Okay, it cannot be a single digit and nor it can be 3-digit. So you know this is going to be square root of 678. This is going to be a 2-digit number. So it will have a tens place and a units place. Okay, so first what we try to do is we would like to estimate the tens digit place, right? So we are trying to find this thing here. Okay, so if we call this digit, let's say A, okay, then we are trying to think of 10A, okay, such that the square of this, okay, now this square is going to be, 100A, and therefore it has to be less than 600, right? In other words, A must be, or okay, with mistake, A square. So A square must be less than 6, okay? So we need to find a number. So let me start writing here. Okay, so we need to find a number whose square is less than 6. Okay, and we need to find the largest such number. Okay, because we are trying to estimate. So, I mean, very clearly, A is going to be 2. So we kind of cordon off this portion. Okay. So let's cover this portion and this side. So this part is, this is 20. Okay. So that's the 2 we write here. Okay. It's actually a 20. So there is a gap here. Okay. Again, if you think in terms of arrow cards, it will be a 20 and then another units digit will come on. So now we are subtracting 400. Okay. And we are left with 278. Now this 278 is nothing but the area of this inverted L, the remaining area. Okay. Now we need to estimate, find the units digit. Okay. Now whatever be the units digit, you see, whatever is this, if we call this B, we can split it into 3 parts. Okay. And let's say maybe, it's not a whole square. So maybe, we want to find something which, fits within the largest possible square that can fit within. So this is, how much is this? So you can see there are 2 rectangles and a small square, which is now it's beginning to look exactly like the A plus B whole square thing, right? So how much are each of these squares? Rectangles.
2 AB.
Louder, please.
2 AB.
Not, okay. What is A here?
So 20.
Right. So this one is nothing but 20B. And this is also 20B. Okay. and this is b square. Okay, so together it's become like, there is a 20b here and a 20b here. Okay, so 20b is getting doubled. So here what we do is, that is why we double this 20 and make it a 4. Now we need to find a b here, right? And we multiply it by the same thing. Okay, so we need to now find a number such that this 40b plus b square. Okay, I'm going to go over to text because that will be slightly easier. Okay, so 40b plus b square, which is nothing but you can take b common, so it's 40 plus b times b. Okay, so that's what we need to figure out, and we want this so that it is less than 278, right? So we need to find such a b. Notice that the number that we get here, the number we get here is nothing but 40 plus b, and we multiply it by b. So the process we do here is basically, again, it's very similar. We are trying to find a b, so the largest possible b that can, so that this area is less than 278. Okay, so any clue what b can be? Any guess? I will try with 5, and if that is 45 times 5, so how much is that? That should be 225, right? So, so we can, that definitely works. And would 6 work? Let's see, 46 into 6. In fact, 6 will work too, right? Okay, so I guess 7 will definitely not work. So let's say 6. So then we put a 6 here and a 6 here and a 6 here. Okay, and let's see what we got. So 6 times 6 is 36. Okay. Okay, so that's pretty good, right? We are just left with 2. So that's a very, very close thing. Okay, so now I'm going to, okay, okay, I have to do it in 3 parts. So that, and okay, I'll do it in 2 parts. Okay, so we have got this. Okay, now we are left with a very, very thin area. Okay, and the area of that little thin white part is 2. Okay, now you have got your 2 digits, so there is no space for anything more. So now we need to get to decimals. Okay, so now we get to decimals. Okay,
Swati,
yeah,
I have a doubt.
yes.
Here, which number you take to divide initially? You didn't mention here. That makes me more confused. If I show it to the children, means they will ask. Usually we do division by, if 4 by 7 means we put 7 outside and we put 4 inside.
Aha. No, I did
Here.
mention that. In the first level, I did mention it. It is here. Okay. You see, we were trying to find the largest A. A is a digit. So A can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We were trying to find the largest A such that 10a whole squared, which is 100a square, is less than 600. So we needed an a square, which is less than 6.
Yes.
That is how we came up with this a equal to 2.
Yes.
Okay, so that is why, because we are doing square root. Okay, so we need the number here is equal to the number there, right? So we don't have a starting number to begin with. In division, we are given that. But when you are doing square root, you don't, it's not given to you. You have to find that. That's exactly the process we went through here. Okay,
It's no need
so
to show that what number we started, right?
yes, so you basically realize that, it's the 6. I mean, this is too small, right? If you are considering, I mean, if you think this is going to be of the font 10a plus b, then you know that the square of 10a, it's going to be a multiple of 100. So this 78 is not going to matter. So you focus only on the 100, how many hundreds are there, and then you try to find the square root. Is that clear?
Yes.
And once you get that, then obviously you get something to put in here. Yeah. Okay. So now what happens is we got our 2 digits. Now, if we want to split this further, then it has to be broken down into decimals, right? So everything becomes like, this has to be, broken into very, very thin parts, 0.1, right? So if we do that, then now, so we have got 26. So now we are looking for, okay. So now we are looking for another number such that so we are looking for another number, let's say C. Okay. So here we already have, again, it will be, split into a very tiny square here and 2 rectangles. So the rectangles will be 26. Okay. Now, if C is the digit, then it is actually 0.1 C. Okay. And there are 2 such rectangles. This is one rectangle here and another rectangle here. So, okay. So times 2. Okay. Plus, we have this tiny square. Now that tiny square is 0.1 C whole square. Okay. Because each side is 0.1 C. Right? So, okay, I have run out of space here. Let's see if I can shift some things up. Okay, so just give me a minute. I think we can get rid of this picture for sure. Okay. Let me see. Let me shift. Okay. Yeah. Okay. Good. Now we put, now this becomes, so 26 here, 26 there, so it becomes 52. We double it. Okay. And then again something. So here we add 2 zeros. Okay. Because see, now, this way it is split into 10 parts, this way into 10 parts. So each tiny square is 0.01. That's why 2 zeros have come in. Okay. Is this part clear? Why 2 zeros came in? because this little white strip, white L-shaped area, it has been split into 10 vertically and horizontally. Okay, so each unit has been split into 100 parts. So that's why, you know, there are 200 0.01s here. Okay. Okay, so now um, now the smallest you can put here is, you know, I mean, if you, it will be like this, right? This is where the C will come in. Now the smallest C that satisfies, I mean, and whatever this is, this whole thing has to be less than 2, right? Okay. Okay. So if we want to ignore all the decimals, then you have to multiply throughout by 100. Then, you know, this becomes 200, which you can see here. This becomes C square, and this becomes 520 plus C, sorry, 520C. Okay. So this way also you can kind of make sense. So if we multiply throughout by okay, so this is what it becomes, and this is nothing but 520 plus C times C. Okay, so this is what this line becomes, right? If you multiply both sides by 200. Again, just like what we did in division, it's the same idea that you know, this area, you split it into 100 tiny little pieces. Therefore, the area of 2 becomes now, you know, 200 pieces, kind of like that. Okay, that same area there we were doing just, you know, splitting into 10 equal parts. So that's why, you know, there was just 1 0 coming in at the end, and it was becoming 10 times more. Here we are splitting it both vertically and horizontally. So 10 times 10, 100 pieces. And therefore, you know, the 2 became 200. Okay. Okay. Now, C equal to 1 is not going to work, right? So the only C we can put is 0. Okay. So we put a 0 here and 0 here and 0 here. So that's it. Doesn't work. So the whole 200 comes. And now we have to repeat the process, meaning that again, all this 200 needs to be split again into 10 by 10, you know, 100 smaller pieces. So number of pieces increase again 100-fold. Okay. So notice every time it increases by 100 here, it you know, it's increase. I mean, okay, I don't know whether to say increase or decrease. Every time it's, you know, 2 zeros here, it's like 1 more 0 here. Okay, because it's square root. Okay, so now it will be again 520, and now there will be a D times another D. Okay, same thing. Okay, so this is now equivalent to finding 520,000 5,200 plus C times C equal to 20,000, right? Now C equal to 4 will be too much. So, sorry, it should be D, not C. Hang on 1 second. Okay. So, if we put D equal to 4, that will be immediately too much, right? I mean, it will immediately shoot up. So we should try with D equal to 3. Okay. So let's do that. So that's 9, 0, 6, 1. Okay. And that's definitely smaller, so it can be subtracted. Okay. And obviously it's not a perfect square, it kind of keeps growing like this. And this is how you can, continue. Okay. But basically this is the idea. You use a plus b whole square and you use place value, and that's how you can kind of go on. And this is how you can actually figure out how much is square root of 2 or square root of 3. Okay. If you use a centimeter graph paper, you can actually try to do this with root 2. Root 2 fits in nicely. Root 3, it becomes a bit difficult to fit it in because, it's 1.732. In a typical graph sheet, you will be able to fit in 1.7 in one direction, but not along the other direction. The paper is not as wide. Okay, so root 2 we have definitely done with children, and that's possible. And you will get up to 1.41. That much you will be able to do. Okay. Okay. Did this make sense?
Yes, Pati.
Okay. So I'll definitely share the link to that article. And in the reference, you will find a link to a PPT, and that also you can look. In the article, the author has tried to look into why we split, usually when you do square root, you basically split the numbers in group, in two, like, you have to start from the units and pair them up like that. Why that is done, so we have discussed, the author has discussed that, and then has dealt with many cases dealing first with whole numbers and then has gone into decimal approximation. Okay, and it has lots of picture like the picture that you see here. Okay, so I'll share that with you. So yeah, and frankly, I have no idea what kind of homework to give based on this. Maybe, you can try to draw some pictures of square root. So maybe I can ask you to do like a couple of examples, maybe. Okay. How about, largest square that can less than a number, you can find that. And how about nearest square? Okay, so these are two kinds of problems I will give. Yeah, and I will share the link to the article. Any suggestion for what you want to discuss next time? Okay, I'm assuming you will need some time to, discuss and come up with that. Just it will help if you let me know by Wednesday or earlier that, the topic that you would like to discuss. Okay.
Swati,
Yeah.
shall we discuss set theory for the next time?
Set theory. Sure.
Okay.
If you have anything specific in mind, like any particular textbook chapter or stuff like that, then that will make life a little bit easier.
Okay.
Okay. So, but yeah, we can definitely discuss set theory.
Okay, sir. Thanks.
Yeah. Okay. Can one of you please just email me this topic so that will just help, remember it. Okay. I think I will be able to share the link right away. Hang on 1 second. Why keep you waiting? Hmm. Okay, so let me put it in chat. Okay, here's the link to the article. And I can put the homework here too. No, homework, let me email because otherwise I will have no record of it. Okay. Okay. I'll make the homework straightforward. Okay. Find the largest square less than 50,000. Okay, that's one. And find the nearest square to 4,000. Okay. When I say largest square or nearest square, so your answer should be in whole numbers. Okay. Largest and nearest squares are perfect squares. Okay. So you're not getting into decimals, etc. Okay, so I guess that's all for today. See you next week.
Thank you, sir. Bye.
Bye.